And now what I want to do is I actually want to take this empirical rule, take these three different cases and sort of combine them into one and go into even more detail. Because a lot of textbooks, they're going to show it like this, and I don't want you getting confused. So what I'm going to do, I'm going to draw normal here, fairly large, so we can see what's going on. And then we have the mean in the middle. And here's what I mean by going into more detail. So what I'm going to do is I'm first going to go one standard deviation to the right, and then one standard deviation to the left. Right? So this is mu plus one standard deviation, then mu minus one standard deviation. And so I'm actually going to create some dotted lines here, splitting these areas up. So this whole area here is 68%, right? This interval. However, this one's not as straight. However, we can actually get into more detail because we know that the mean is right in the middle. So let's make a line for the mean as well. And so we know that both of these areas add up to 68%. And because it's symmetrical, we can actually split that 68% up. So this could be 34% over here. And this could be 34% like that. So we're getting even more specific now. And I'm going to show you why we're getting more specific. We're going to go over a couple of examples where we do have to actually use these numbers. So now let's go out to two standard deviations. So if I got a mu plus 2 times sigma, and then I got a mu minus 2 times sigma, let's create vertical lines for that. And now notice that we got these two new areas that were formed. So what's the proportion of the data that's going to be in these two areas? How do we figure that out? Well, we know that 95% of the data is going to fall between these two values, right? So this whole thing here, between this and that, all within that is going to be 95%. But we already have 68% covered with this area here. And so the total of these two areas is going to basically be the total 95% minus the 68%. Which is going to be what? 27% remaining. So both of these areas have to add up to 27. And because it's symmetrical, that 27% is going to be split up evenly. So we would divide it by 2. So 13.5. So this area here is going to be 13.5%. This is going to be 13.5% as well. Okay, and now let's go out to 3 standard deviations. So getting a little bit more precise now. So we got mu minus 3 times sigma and then mu plus 3 times sigma. Let's draw a dotted line. Let's draw a dotted line. Now we know in total within 3 standard deviations, so this whole area is going to be 99.7%, right, from that empirical rule. Well, how can we figure out this area and then this area? Well, all of this totals 99.7, and notice that we've already covered 95 from here to here, right? So if we add these 4 areas up, it's going to be 95. So what's remaining is basically the total 99.7 minus the 95, which would be 4.7% remaining. Okay, but then that 4.7% is going to be split up evenly between these two. So 4.7% divided by 2, this would be 2.35%. That's going to be 2.35%, like that. And then these areas, we actually went over when we discussed the empirical rule. It's basically the areas remaining in that third case, because the whole thing is 99.7. And so remember, 0.3% is remaining. So we split it up evenly. That's going to be 0.15%. This is going to be 0.15%, like that. Okay, so if you take all of these numbers, all of these areas, there is how many? 8 of them? 1, 2, 3, 4, yeah, 8 of them. they would add up to 100%. Okay, so you could get even more detailed. And by the way, in certain textbooks, they may not present this. Some textbooks will. And if they do present this, sometimes it'll be in decimals, in proportions, not in percentages. So for example, this 0.15%, if you want it in proportions and decimals, you would divide it by 100. So it would be 0.0015. This would be 0.0235. This would be 0.135. This would be 0.34. Okay, so sometimes it will be in decimals, right? So don't get confused about that. I'm just going to keep it in percentages in this video, just to keep it simple, but very possible that it could be in proportions. So now, why do we need to split up these areas like that? Well, you may get certain examples like this one that I just wrote out, where you're going to have to use these areas. So I'm going to do a bunch of examples. This is going to be one of a few. So notice that we're told for a normal with a mean of 17 and a standard deviation of 4, how much of the data, or what proportion of the data, is in between 13 and 25? Well, let's fill this axis, this x-axis in. These are also called z-scores. We're going to talk about that in a future video. But let's fill in this axis with those parameters. So the mean is 17, so that's in the middle. And then standard deviation is 4. So we know this is going to be 21. This is going to be 13. This is going to be 25. This is going to be 9. And then we're going to have 5, 29, like that. So how much of the data is in between 13 and 25? Well, notice we can just count this area, and this area. We could sum those up. So we would have 34 plus 34 plus 13.5. And when you sum those up, what you would get is 68% plus 13.5. So you'd end up with 81.5% of the data. That would be the answer to this. And notice that would be tougher to get if we just kept it as 68, 95, and 99.7. Because we went into more detail now, we can deal with more detailed intervals. Let's try another example. So let's say we have a normal with a mean of 40 and then a standard deviation of 6. How much of the data is, we got two questions here, in between 28 and 58, and greater than 52 and less than 22. So let's fill in this axis here. So we got 40. If we add 6, subtract 6, add 6, subtract 6, add 6, this would be 58, and then subtract 6, this would be 22, like that. So now we got more detail here on the axis. So in between 28 and 58, so basically in between this value and that value. We can just add these areas here. So we actually know that this, and that add up to 95. Then we got to add this 2.35. So 95 plus 2.35, that would give us 97.35%. So that's the answer to number 1. So look how detailed we're getting. Greater than 52 and less than 22. So now this is not really an interval. It's kind of two separate areas. They're asking for this area and then less than 22 plus this area. Greater than 52 and less than 22. So we know less than 22, 0.15%. But greater than 52 is 2.35 plus 0.15, and then when you add these, you would get 2.65%. Right? So this here, the answer for number 2 is 2.65%. Right? So just a couple of examples of where going into this more detail helps in answering these types of questions. Sometimes you're going to have to do that. And actually what we're going to cover later on in the section in later videos is going into even more detail. So notice that these questions that I gave you, these numbers here, they sort of fall nicely of where we're taking that mean and we're either subtracting or adding a few standard deviations. Like the 28 is nicely here, the 58 is there, the 22 is there, the 52 is there. But what if I ask you a question, what proportion of the data is in between 29.2, which would be like there, and let's say 48.76. Okay, how would you figure that out? And not just approximate it, but get an exact value for this, right? Because notice that these numbers, they're not falling on these nice numbers where we're taking the mean and we're adding or subtracting a few standard deviations. These are like within these intervals, right? So how do we get exact values for this? There's actually a process for that, and we'll cover it in later videos.